All right. So again, thank you for everybody for coming, and also for people who are returning back. Thanks for showing up. So again, we'd like to always acknowledge PyData people that are helping to sponsor. So NumFocus for sponsoring the meetup itself, TD Ameritrade for the venue, Arbor Spark for helping with some of the advertising, and also Midas, who usually provides food. But we're working on it, so I promise that that pizza is coming at the end of this. So we should still thank them, though. As always, important points for people who have not been here. Emergency exits. There's one right here, and there's one right outside the door that you entered. We're always soliciting for speakers, especially local ones. Okay, so we do have a lineup of a lot of speakers that we'd like to invite, but we would love for people around the community to talk. And then always provide Ben and I, who's Ben over here, any feedback. So please tweet at us or send us a message on Meetup. Let us know how we're doing, things that you would like to see, speakers that you'd like to come give a talk. And you can always grab a lot of the speaker slides. Hopefully Jennifer will share those slides afterwards. We like to post it up on the PyData and our Arbor GitHub page. And just to be mindful of time, unless the question is quick, please hold them until the end. We kind of got a little bit carried away last time. And also remember that we're in borrowed space, so please do clean up after yourselves if food shows up. And for newcomers, I'd like to sort of remind us of the PyData Code of Conduct. So PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriate for any of our meetup events. Please be kind to others. Do not insult or put down other attendees. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the meetup at the sole discretion of the meetup organizers. But thank you for help making this a welcoming and friendly event for everybody. Okay. And as always, an icebreaker. Today's icebreaker is so that you get to meet somebody, hopefully, before we leave. Today's icebreaker is choose between the following two options. Superpowers. Either flying or invisibility. Turn to your neighbor, choose one, and explain why you choose that one. Introduce yourself, don't forget that. Go ahead.
Hi, I'm Jennifer Marsman. I really wish you would have made shape-shifting part of that, because for shape-shifting, you would actually get invisibility by shape-shifting into a plane and flying by shape-shifting like a bird. So that's what I would choose if that were an option. If I have to choose shape-shifting and invisibility and flying, that's really hard. I think invisibility would probably be more beneficial for my life.
Okay, so I think we have different
flying would probably bring more of the
I'm still assuming we're going like 40 miles an hour.
This is like superability. I don't do it. It's not like
That's a possible elimination.
Well reasons.
I've
had somebody tell me that I want really strong hands.
Okay, that is interesting.
Like some crossfit.
But I'm saying that's outside of the specification.
But uncontrollably strong.
Yeah. Okay. There you go.
All right, we're back. Thank you.
Talks about
also, we'd like to point out our data science thing of the month. This month is a blog post, or actually no, it's a book. It's an online book called From Python to NumPy. So if you typically code in Python and you're trying to figure out what are some of the nice ways to do vectorization or to speed up your Python code, this blog post is fantastic. This is one of the examples where they code up how to do this, I guess, classic computer science problem called voids. So these are actually birds, digital birds that are flocking together and flying together. And they show examples of how one would code that up in Python and using the standard lib, but also how to do that in NumPy. They got tons and tons of examples. Again, this will be posted on our GitHub page, so I urge everybody to go check it out. I absolutely love this, and they've got tons and tons of content there. And we want to do a quick poll just so we know what our audience is. How many here are currently in academia or in school or what was recently in school? Okay, and then how many in industry, corporate world, working, transitioning? Cool, about 50-50. Excellent. All right. And don't forget to tweet out at PyData and Arbor to grab your free O'Reilly ebook. And also TD Ameritrade, we're hiring, so either a senior software developer or a senior data scientist. And also don't forget that our next event is coming up on Thursday, July 13th, and we're having Gus Gordon from Quantopian coming, talking about designing an algorithmic trading strategy in Python. And I think Ben wanted to mention something too.
Yeah, so we have these events once a month. We're looking to maybe expand to maybe doing some workshops or something a little bit more hands-on. Marcus has been generous enough to help kind of lead those things. But we don't know where we should start first, because we don't know much about you. So if you feel like sharing, maybe tweet at us about the kinds of things that you want to do that's a little bit more hands-on. Like, these events are great, we get to learn about what's going on, but maybe there's something that we want to do a little bit more intro to that's interactive, like how to use Docker, how to use Kubernetes. We had a few of those questions last meetup, or an intro to NumPy, or maybe advanced NumPy, or those kinds of things. If there isn't a large response, maybe we won't do it as often. But if there is a large response, we'll try to do them maybe on the every 2 weeks or something like that. But we're going to start off with just one and see how it goes.
Tell us what you want. So without further ado, we have Jennifer Marsman, who's here today. She went to school not too far from here at the university.
Go Blue! Yep.
Both her undergraduate as well as her master's. And currently she is a developer evangelist as well as a principal software development engineer.
Wow, you didn't even look at the sheet.
At Microsoft. This is code of conduct, by the way. And so let's give her a round of applause.
It is on. Hello, everyone. Thank you so much for having me here. I really appreciate, and I have a feeling I'm going to love this crowd just based on the spirited debate around the superpower thing. I think we're all on the same page here, so it seems like a really good group. So what I wanted to talk today about is specifically an introduction to Azure machine learning. So just so I have a sense of those who are in the room, how many of you people are machine learning experts, or consider themselves machine learning experts? Awesome. Okay. And then how many people have a basic familiarity with machine learning? Okay, awesome. And then how many people are primarily think of themselves as a Python developer but not necessarily know much about machine learning? Okay, cool. All right, so the reason I asked is we were talking about, like Sean and I were talking about what talk to do, and I thought that maybe this would be a good one. It's a new tool or something else that you could have in your toolbox in terms of when you're writing code and such. And there's a little bit of kind of some data science in here. So I'm hoping it's not too introductory. It may be too introductory, and you guys may be beyond this, so we'll see how it goes. But this is one of the just basic intro talks I do in machine learning. So if you have more advanced questions, feel free to let me know those at the end of the talk as well, and I'm happy to jump into those too. All right, so what we're going to do is I'm going to start with just like 10 slides, do a little context for those who don't have the machine learning background on supervised machine learning, and then the majority of it I'm just going to spend on demo. So we're going to dive into a demo and talk about specifically who would survive the Titanic. How many people have heard of Kaggle? Okay. Oh, yeah. You guys are a great thing. So we're going to go through the Titanic Kaggle challenge, which sounds like a lot of you are familiar with. And by the way, Ben and did they both leave? Ben and Sean, my vote if we do hands-on is I think we should all get together and do a Kaggle challenge together. I think that'd be fun. My vote for the hands-on thing is like let's all get together and do a Kaggle challenge. I think that'd be fun. Yeah. But okay. So let's get started. And my contact information is there. If you have any questions that weren't able to be answered, feel free to hit my blog or Twitter or anything. I'm pretty easy to find online, hopefully. All right, so let's start with just kind of the basics of supervised machine learning. So machine learning all up, there's several different categories of it. Reinforcement learning, where it's kind of a turn-based thing, and you can get rewards and benefit, or rewards based on kind of moving towards closer to your goal. And such. There's unsupervised learning, which you can do things like clustering and things like that. And what I'm going to focus on today is supervised machine learning. And so what that is using a series of historical data to be able to make future predictions. So for example, one might want to predict the cost of a home, all right? And so if you wanted to do that, what you would need is something that we call a label. So here is my labeled, I have a labeled data set here of the various homes and how much they actually cost. And then I also would have what we call features. And features are things that would affect that label. All right, so if I'm trying to predict the cost of a home, the square footage may be very relevant to how much it costs. The zip code, right? Because a house in Silicon Valley that's 3,000 square feet is going to cost a very different amount than a house in Detroit that is 3,000 square feet. There's also a number of other things, right? Number of bedrooms, number of bathrooms, size of the master bath. For some reason, people really care about having a big master bath. A number of years since the kitchen's been, renovated, those kind of things. So there may be a whole bunch of different features like that. And we would have, in real life, we would have more than just two. This is a very, very simplified thing. So we'd have more than two features, but we have a whole bunch of features and then some label that's associated with them. So for this historical data, this was the right answer. This was the price. And then we would have a lot more rows than this too. You'd want a lot of data to represent you get a good general sense of a bunch of different scenarios across the data set that you're trying to get information on. So and then all that supervised machine learning is doing is using crazy beautiful math to find the correlations between these features and that label. And the actual way it's done is different depending on the type of machine learning algorithm that you're using. So you guys may have heard, you guys are all, I think in this room everyone is maybe familiar with these already, but the difference between like neural nets and Bayesian algorithms and decision trees and linear regressions. So they're all just different kinds of math that help you find correlations between those. And the math is all a little bit different, so some of them work better in certain situations than other ones do, just based on kind of what your data set looks like. All right? So that's what machine learning is. And then, so it finds the correlations. We build a model that represents, okay, based on all this data that I've consumed, my training data, I build a model, and then I can pass it, that model that I've created, I can pass it just the features now that I kind of have learned from this historical data, I can say, all right, so for a given square footage and zip code and whatever other features we choose, how much should it cost? And then based on what it's learned, it can give me a price back. All right, so that's kind of the very basics of supervised machine learning. All right, and so in Azure machine learning specifically, there is support for 4 different categories of algorithms. There's actually 25 underlying algorithms that are in there right now. And there's support for kind of, in those, in general terms, are 4 different categories. And so the first 2 are classification and regression. So classification and regression are both examples of supervised machine learning that I was just talking about. The difference between them is classification is when you want to predict between multiple discrete buckets, right? Is my husband lying or telling the truth? Is this particular, is who's going to win the big game, Michigan or Michigan State? Is someone going to get readmitted to the hospital within the next 90 days, yes or no? So those kinds of things. It doesn't have to be binary either. It doesn't have to be just 2 options. You could say, this set of pixels, which color does it map to? Red, yellow, green, blue, and have 4 different options. So there can be multiple options there. So that's classification, discrete buckets, right? If you're coming from just a developer background, think about basically anything that you would create like an enumeration for, right? Like I have these different kind of states, and then I'm assigning them all a number, and you can build a classification algorithm. All right, the other one is regression. So regression is actually, this example right here is a regression problem. Regression is when the thing you're trying to predict is a value on a continuum or a number. So in this case, even though in my training data, if I just use this amount of data, I don't have anything that's $2,500,000, but the model could still predict $2,500,000 because it can extrapolate or interpolate between those values, right? With classification, it's only going to use the discrete buckets that you define in the training set. Regression it's going to predict a number, and it can find new numbers outside of your training set and that sort of thing. All right? Fabulous. All right. And then, so an example, and I think breast cancer is, does this person have breast cancer or not? Maybe another thing. Predicting the price of a home, regression. Anomaly detection is kind of an interesting sample for a very specific problem. So consider the problem of credit card fraud detection. That's actually kind of a tricky problem because when you look at a typical credit card transaction database, what it usually looks like is you have all of these valid transactions, right? A lot of valid transactions. And then you have a very, very small subset of them are fraudulent transactions, or hopefully it's pretty small fraudulent transactions. And then the known fraudulent transactions is even smaller still, right? So here's my known fraudulent transactions, and here's all these, valid transactions. And it's actually really hard to build a model when you have a highly unbalanced data set like that. When it's like all of these map to, valid, and all of these small number maps to fraudulent. And so techniques like anomaly detection can actually help account for that, where you kind of say, this is the realm of normal, and then these are have anomalies. So you can use this for credit card fraud detection. You can use it for network intrusion detection. Microsoft does that for some reason. Who knew? People actually love to hack the Xbox Live gamer system. Who would think? Who would have thought? But people really, really, really want to get more gamer points, and so they try some really funny things to be able to do that. So anomaly detection is a good thing you can use there. There's also a kind of an interesting thing that I did once with a group of folks down in Texas that were dealing with the issue of oil and gas pipelines. So I don't actually know a ton about the oil and gas industry, but apparently, these are very precious natural resources. I do know that. And so sometimes people will actually try to siphon and they're these huge pipelines, okay? And they run through these places in Texas and Alaska and such where there's just no one there for miles and miles and miles. So black market or whatever, people will sometimes try to siphon off oil or gas or something from these pipelines. And I mean, best case scenario, that's stealing, and it's wrong, and they shouldn't do that. But worst case scenario is that a lot of these materials are very volatile and can explode fairly easily. And so things can happen and entire pipelines can explode and really, really bad things can go wrong. And so we were designing anomaly detection for detecting that something was going wrong or the pipeline flow is being reduced in something that was outside of normal and stuff. So that was kind of an interesting problem as well. All right, and then finally, clustering. So clustering is an example of unsupervised learning. These have been supervised learning. So unsupervised learning, you don't actually have to have a label with your data set. So you don't need a labeled data set like that. You can just have a whole bunch of data and maybe do something interesting with it. A lot of times in recommendation engines, you might want to do some clustering first. So if I wanted to recommend a restaurant to you or a good movie to see, you could cluster, like restaurants together or like movies together, that sort of thing to be able to make a recommendation to someone. Okay? All right, so that's kind of so Azure Machine Learning has support for these 4 categories of algorithms, and then there's a whole bunch of algorithms inside of each of these. So all of that I've talked to so far up to here is just kind of machine learning in general information. So this is a little bit more specific to Azure ML. So Azure Machine Learning has 25 different machine learning algorithms inside of it. And so basically, it's a very, very easy to use, drag and drop interface. We'll do that today. I'll just build one from scratch, and you can kind of see how it looks and have it as another tool in your toolkit if you like. There are modules for importing data, cleaning data, and doing all kinds of things. Of particular interest to this group, there is an execute Python module in there. So what you can do is actually drag and drop in a little module and then be able to run your Python code in there. And there's actually a lot of companies that I'm working with that are using Azure Machine Learning just for that. The deployment story is actually pretty nice because you just hit a button and it deploys and that sort of thing. So they're actually doing their, writing their Python and then just creating a whole, a machine learning project that's just one module of execute Python and then using that to run the whole thing. So anyway, you guys will see that and we can talk about that more at the end if you like to do that. I'm seeing some smiles, so there may even be some people in the audience that are doing that right now. But we can talk a little bit more about that, and I'll show you some of the cleaning and all kinds of good stuff that we can do. But you wire up these things. It's a very easy kind of drag and drop, wire up a data flow. You can train your models, test your models, and then the deployment really is pretty beautiful. Coming from someone who hates dealing with deployment, it's literally like a button press, and then it stands up a REST endpoint for you, and it generates code in 3 different languages for you to actually call the endpoint. It creates a GUID to use as your API key, so that way it's secured. Only people with the API key can access your endpoint. So there's just a kind of a nice publication model too. So, okay. All right. So here is one potential way of doing supervised machine learning. There are others as well, cross-validation and some other stuff, but we're going to kind of look at the simple case here. So we're going to start with some data set, and we'll see how to do that. And then we can do a series of, we can do various data cleaning. Depending on the data, you'd want to do different things to get it in a format that can be easily consumed by a machine learning algorithm. And we'll look at that when we get to the demo. And then the next thing you want to do is split your data. And the reason we do this in machine learning, even though I think a lot of people in this room already know, is because if I just used all of my data, so if I took that whole percentage of training data, built a model to train it, and then I took, let's say, for example, if I'm using this guy and I feed all this data in, and then I ask it, okay, model, what is a house that is 2,000 square feet in zip code 48075? How much is that going to cost? You trained it on that data. So that's something that it kind of already knows. And so really the good test of how well your machine learning algorithm actually does is how well can it do on data it's never seen before. So typically what's done is you can split the data, and there's lots of different ways to do that. You can also use cross-validation where, let's say, if our K was 10, we could split it into 10 different chunks and then use 9 of them to train and then test with the 10th one and then use a different 9 and then apply that 10th. So there's various ways to do that. There's support for that in here as well. But I'm kind of showing the simple example is if your data set is large enough, you can usually just do a random split and that will work just fine. So we want the training data to be the majority of our data set. So typically like a 70-30 split is just fine, but there's variations in that. You can do 80-20 or 75-25. But let's say we take 70% of our data and we use that to train our model, and then we have some algorithm that we use, and that defines what the math is to find the correlations between that feature and that label, remember, okay? And then what we can do then is that will spit out a trained model for us, and then we can take that 30% of the data we held back and then feed that in. And so what will happen in this score model is it gives the just the features, so just those features into the model produces outputs, but then you can compare them to those known right answers that you have since you held back that data and see how well it does. And then based on that, it will score the model, and then you can actually do the same thing right over here in this another model. Oops, I should probably be using the pointer if this is being recorded. You can do the same thing over here by maybe I start and I do kind of the same cleaning and I split my data. And in this case, maybe I'm training another model with a different algorithm. So there's a little bit of art to data science, right? So I try maybe a couple different algorithms. Maybe I start with a linear and a nonlinear one, and then I kind of try a couple different things. So you can kind of do 2 of these in parallel, compare them against each other, see how well they compare, iterate, and then maybe once I'm happy with the algorithm, maybe I want to start tweaking the initial parameters and saying, okay, these parameters that I'm passing in, how well are those performing, that sort of thing. So you can continue to iterate on this until you're happy with your model, but this allows you to compare 2 side by side to help you with that iterative process. All right. And so then the next question you might have, if you weren't a machine learning expert, was, okay, maybe this kind of makes sense, but then this algorithm that you have here, if Azure Machine Learning has these 25 different algorithms, how do I know which algorithm I should use? And enter the Azure Machine Learning cheat sheet. And I actually have just a couple of these up here as well. So if you want to grab one afterwards, you're welcome to take one. This is the older version, and this is the newer version that I'm showing right here. But essentially what this is a large, friendly, don't panic button in the middle. And then it tells you what you want to do, or you can kind of look at what you want to do. So if you want to find unusual data points, you would do anomaly detection. If you want to kind of discover structure and grouping in your data, maybe you want to run clustering on it. And then we have our predicting values and predicting categories for regression and classification, like I talked about before. So let's do a quick quiz here. If I have a whole bunch of demographic information about passengers on the Titanic, such as their age, their gender, their how much they paid for their ticket, like that sort of thing, and I want to predict whether they survived or tragically perished, would I use clustering, anomaly detection, regression, or classification? Classification. 10 points to Gryffindor. All right, so I'm predicting categories. Now, am I predicting 3 or more or 2? 2, right. There were no zombies on board the Titanic. Everyone has one or the other. So there we go. So now what it does is it takes you to kind of this section here where it kind of, in this version of the cheat sheet, it gives you kind of where each algorithm shines. So this one, like SVM, support vector machines, are really good when you have a large feature set, when there's a lot of different features. They do really well. Some of these are linear. Some of these, the decision trees, there's a bunch of ensembles of decision trees here, and those do well, but like a boosted decision tree is going to have a larger memory footprint, for example. So it kind of tells you a little bit about where each one of these might do well, and then you can do that. And then the older version of the cheat sheet, which I have for some of these, and it's on my blog, and I can send you a copy. I have it downloaded if you really want to see that one as well. But it's this one is a little bit more, it's more like flowcharty, which I kind of like a little bit better because this one is more like declarative in nature, and this one's a little bit more, it asks you questions and then you follow the lines, and I kind of like that one better, but it all depends on how you best learn. But anyway, there are these resources like this to help you if you need it. All right, so if you do want to download it, I did stick a link online where you can grab it. And then I also have a blog post on kind of getting started with Azure Machine Learning. I did write it specifically for a student audience, for some students that were doing a hackathon. So the actual title is How to Win a Hackathon with Azure Machine Learning. So you can ignore the spin in the first paragraph if you want, and then just the rest of it is really just how to get started with Azure ML. But it's got some interesting information, like where can you find, if you want to like just do more with machine learning or try it out more, where can you get interesting data sets to play with? And where can you, and then there's kind of a walkthrough tutorial that helps you find end-to-end. There's information on like retraining programmatically and some of this other stuff. So there's kind of a whole bunch of interesting stuff in there. So, and the link to the feature requests section, which is actually really, really interesting because you can see their features where they're like, oh, this is in progress. And then you can kind of cheat and see like, oh, what's coming. There's actually some nice giveaways on that site too. So good stuff. Okay. So that's that. So let's talk a little bit about data ingestion. There's actually 4 different ways to get data in Azure Machine Learning. And there is a blog post and a video of how to do it right there. But let's actually just go through it. So we're going to start the demo now. So I'm going to jump over here, and we are going to go to a new experiment because I want to do kind of show you everything from scratch here. One thing that I will say, we don't really have time to do this today, but when you get a chance, just browse through these samples because they are awesome. There's a lot of neat things here. You can see, you guys are probably familiar with the various test sets of like handwritten digits and being able to map those. And then there's some really good stuff there's a nice anomaly detection. I've used this sample a couple times. There's some neat classification problems. There's some like customer CRM type data here, predicting like customer churn and stuff like that. There's a network intrusion detection sample, a flight delay prediction, a sentiment analysis one that's kind of interesting to see what people are saying about your brand on Twitter is kind of neat. Some clustering problems, finding similar companies and clustering colors together. So there's all kinds of neat stuff. Ooh, that one's new. I don't remember this one. The presidential campaign finance data. I haven't seen that. Okay, we're going to brush over that real fast. So a lot of cool stuff in there. So check that out at your leisure when you get a chance. But this is what it actually looks like. So it's a browser-based thing. You don't have to download anything to use Azure Machine Learning. You can just go to studio.azureml.net and try it out. There is a free trial version available where basically you can use it you can use it even without a Microsoft account, and if so, you'll log in, you can use it for 8 hours, and then I think after 8 hours, it shuts off. If you do have a Microsoft account, so it's one of those things where you can get a free account, you might have a Google account, a Microsoft account, those kinds of things. But if you log in with your Microsoft account, then it will associate that with your with your Microsoft account, and it will actually be saved, and then you can come back and use the same things over and over again. Yes?
And in their price plans, do they have anything for academia, like student researchers?
The question is, in the price plans, do they have anything for academia? The answer to that is no, but I'm trying so hard, Marcus. I really am. So we do have the DreamSpark offering for students. But however, for some silly reason, I don't understand why, every other offer that we have around Azure is price-based, right? It's up to X amount of money per thing. DreamSpark is the only one where it's both price constrained and feature constrained. So like with the DreamSpark, I think it's like websites and virtual machines and a couple other things that they think that students would be most interested in, but it's like, machine learning, how would they not be interested in machine learning? Like, rah! So I have been making this point loudly, ladylike but loudly, over and over again, and so far I have not made any progress, but I will keep trying. Yeah, but I'm sorry. There's not a really great answer yet. There are a couple things. I think there is something on the web. Let me pull it up at the end, but I think there's a blog post on the Azure Machine Learning blog that shows a couple different ways you can do it, but there's also ways to get like some free credits and stuff like that too. And you can use the free trial, and I think I might even have some of my Azure passes laying around too. So there's probably ways, but it's not as easy as it could be. But anyone can do free. There is a free tier, and I think they assume that like students can just use that if they want to use it. Just use the regular free tier that anybody can use. All right. Any other questions? All right. So let me start with the 4 ways of getting data into Azure Machine Learning and then we'll do the Titanic stuff. All right. So the first thing is saved data sets. So if you want to do this, one thing you might want to do is just kick the tires, check it out, in which case you could just use some of the sample data. So the first one is sample data. So when you start and launch Azure Machine Learning, there's a whole bunch of interesting data sets in here. There's some automobile prices, the UCI bike rental data, which is a very famous one that's used over and over again in machine learning classes and such, an RGB image of Bill Gates. In case you want to do like facial detection or anything like that, is fun. Some book reviews if you wanted to do like a recommendation engine, a whole bunch of breast cancer data, some great CRM data, the flight delays data, this German credit card data, which is nice for the fraud detection stuff, some various movie data, the handwritten digits, if you want to map, okay, this is a 6, this is a 7, more movie tweets and stuff for your movie recommendation engines. So there's like all kinds of interesting data in here. So you can check that out. There's some Wikipedia data, a scrape of Wikipedia. So there's all kinds of fun stuff to play with. And then to use it, you just drag and drop it onto here, and then you can wire stuff up. All right. So way number 1 is sample data. Second thing you could do if you wanted to upload data is you can do, if you have some data locally that you want to send up here, you would do that as a new data set. So for example, I have some data I did from a project that I worked on that is stored as a CSV locally. And so to do that, this one's the trickiest one because you'd think that most of the stuff is all under here. But when you want to upload it from the local thing, you actually have to do new and then data set, and then you upload something from a local file here. And so you select some data on your hard drive, and then it supports various different types, CSVs, TSVs, SVM lights, and a couple of others. There's R data as well. Does anyone here do R as too? All right, nice. So we got the cross. Nice. Awesome. So you can upload all of those as well. So that's another way. And then once you upload them, it'll show a little uploading right here. And then once they're uploaded, they'll appear here under My Data Sets. So then you can drag and drop them into here. All right. So that's the second one is that. So let's do the Titanic training set right there. So that's an example of an uploaded data set. Then the other 2 ways are found right here logically under data input and output. The third one is enter data manually. So with this one, what you can do is specify a data format. And then if you have a header, you could say something like square feet and the price, and then do some more data. The 2,000 square feet is 200,000 or something like that. Now, my friends, one wouldn't really do this in real life. In machine learning, you need a bunch of data, and you're not going to hand type all your data because that's crazy talk. So there's two scenarios I can think of where I find this actually useful. Number one is demos. So when I'm doing demos and I want to just something real quick, you can use it for that. The second thing is like a lookup table. So sometime you might want to do just a quick lookup table and you might just type that out by hand. So for example, if you're like the flight delays data, if you wanted to do a lookup table that BNA actually means Nashville and DTW means Detroit, and, you know, kind of have a lookup table for like airport codes or something like that. Awesome. Like maybe you would use this to do that, but there's not a ton of other scenarios. Yes, sir.
You could use it for corner conditions. Create easy data to see how your model.
There you go. I like that. That's a great scenario. So creating corner edge cases, like maybe throw in a little sample data of crazy cases just to feed in there and see how it does. Great scenario. Awesome, awesome. Okay, so that is entering data manually, another thing. And there's a bunch of different formats for that as well. So you can see we have support for various things here too. All right, and then finally, the last one is importing data. And import data is used when you want to basically suck data from somewhere else on the internet. All right, so if you're kind of uploading it locally, you use that new data set. If you're pulling it from somewhere else on the internet, you would use this. And so you can pull stuff over HTTP. Here, let me zoom in a little bit. You can pull stuff over HTTP. You can run a Hive query if you're doing any kind of big data scenario where you're using Hadoop or HBase or something like that, and you can execute a Hive query against it to get some data back. And then all of the Azure SQL database, Azure Tables, and Azure Blob Storage are all supported. You can use a generic OData feed provider. You can actually access an on-prem SQL database in a secure fashion. And then Azure Document DB, which they actually just renamed to Cosmos DB. And I guess they didn't update it in here yet, but that's fine. So that's just like it's like MongoDB. It's a non-relational database format. Okay, so then if you pick one of these, so let's say I wanted to use an OData provider, you can just go there and then kind of feed in all the other information that you need and then be able to grab data from there. Okay, so that is that. So now let's start. I'm going to actually delete all this. So those are the 4 ways that you can grab data into here. So I'm going to go and delete all of this now. And we will start with the Titanic. So first of all, most people in the room have heard of Kaggle, but the rest of you are in for a treat. Kaggle is the best. So the reason I love Kaggle is because if you want to just like get better at machine learning and do machine learning, there's really 2 things you need. Number 1, you need an interesting problem to solve, right? And then number 2, you need data to solve it with. So you have to have both of those things. And what I love about Kaggle is it gives you both. It gives you exactly what you need. So if you just want to like get better at machine learning and just play and learn and maybe even win some amazing cash prizes, like you can do that. So Kaggle, it's Kaggle. Kaggle, K-A-G-G-L-E, Kaggle. And what it does, and actually Google just bought them, and I was so mad because I wanted to buy them, and it didn't, they beat us, and I was like really sad, but that's awesome for Google. But so what they can do is they're hosting a competition, they host data science competition, so it's really, really cool. And Microsoft has hosted things on here, Yelp, Facebook, Google, like a lot of people have hosted kind of really interesting things. You can see we have Zillow and Intel right now and some other cool stuff. But basically what they do is you can click on each one of these and they give you a really neat kind of challenge and kind of explain the problem. So in this case, this is for Zillow, it looks like they want to see, can you predict the example I was talking about at the beginning? How can you predict the value of a home? So kind of an interesting problem there. Cervical cancer screening. That's awesome. Like how cool is that to work on a really like fulfilling challenge like that and be able to maybe make a difference. And so you can see they actually, a lot of these big corporate sponsored ones have large cash prizes. There's also kind of some interesting things using satellite data to understand the Amazon rainforest from space and some other things. But if you click on any of these, you'll get some neat information about the project. And so there's a whole bunch of sponsored ones here at the top. And then there's just kind of some ones for learning as well. So there's like a playground one, and then these are kind of some getting started ones. And so if you look here, I'm actually using the Titanic example data set, and I have already downloaded it from Kaggle. But what it gives you is all of this demographic information. And with the demographic information, it gives you information on, where good thing I've already downloaded it, so we're all set. But that's kind of sad. Come on, Kaggle. Oh, Google buys them, and look what happens. I'm teasing. I actually love Google. So did anyone know Larry Page when he went to U of M? Okay. All right. There you go. Okay, cool. I met him at U of M. So no, I think a lot of Google. Okay. So what we're gonna do is I'll skip over that, but essentially what happens is each one of them have like three, kind of a series of sections on the Kaggle page where they give you a kind of a description of the problem. So here's the problem. Then they explain the data set. So there's all this kind of neat information about the data and what kind of cool things that you can do, and kind of like here's what these different values mean if there's like some letters or kind of odd numbers in their description of what the column headers mean and all of that kind of thing. And then they give you a place to submit. All right. And then you can submit as many times you want through the conference thing. And what's interesting is they have a public leaderboard. So you can submit, you can see exactly where you're ranking on there. But then what's cool is when they actually close the contest, they use a different set of data to run the final competition. So the person that's number one on the leaderboard still may have overfit their data to that particular, set of data that the leaderboard was on, and may not end up winning number one on the actual competition. So it's a really fun way to kind of hone your machine learning skills. I'm a big Kaggle fan as well. All right, so we're going to start with the Titanic training set. I've already downloaded it, and I'm going to utilize it from right here. So the next section is let's just kind of explore this data set, and I'm just going to kind of brain dump all of the things I think about when I look at this data set, and then we'll go back and implement it after that. So I'm going to just right-click on there and hit Visualize, and then in the Azure ML tool, I wonder if there was no. Okay, good. I'm just going to kind of talk through all this data, and so we'll talk through what we would do with it first, and then I'll go back and implement all of it. So we're going to kind of do exploratory first. All right. So first things first, we can see here that there are 891 rows in this data set and 12 columns. So, okay, good information. Then if I click on any of these columns, so if I click on the first one, passenger ID, I get a whole bunch of information about it just looking at it. And so just by eyeballing the first thing, 1, 2, 3, 4, 5, 6, it looks to me like that is a randomly assigned integer and the name being passenger ID. It looks like a randomly assigned integer, but I can actually confirm that by seeing that the minimum is 1, the maximum is 891, and there are 891 unique values, which is the same as the number of rows on the data set. So confirmed, that is a randomly assigned integer. So do we want to use that as a feature in our machine learning algorithm? No. That's essentially noise. That has nothing to do. You wouldn't want to do a decision tree that says, if passengers' IDs was 7, then they die, because then that doesn't extrapolate well to new data, right? So that's something we would want to drop. Ordinarily I would drop it, but the thing is with Kaggle challenges, you actually, the format they want you to submit it in is actually passenger ID and then the prediction. They want like just those two things in a big CSV. So what I'm actually going to show you how to do is how to keep that value with the data, but not use it as a feature. All right, so that it goes through the data set, and then you can actually have it associated with your output, but we won't use it as a feature. So I will show you how to do that. All right, the next thing is survived. So this, if you look at the Kaggle thing, what it says about it is actually whether or not they survived or tragically perished on the Titanic. And so we can actually look at a little bit more information here. If you look at the visualization section, you can see in this data set that I have that approximately 62% of the people tragically perished, and then about 38% actually survived. And there's, all kinds of interesting data here, kind of the min-max and 2 unique values. So this looks good. We want to keep this data. This is not actually a feature though, right? I want this to be my label, yes. So I'm going to turn this from a feature into a label is the one thing I would like to do with this. The other thing I would want to do with this is right now it is a numeric value. However, I don't actually want to do like math with it, right? When you think about sometimes there are numbers that you don't want to actually treat as numbers. So think, for example, of the zip code example that I used in the regression problem at the beginning when I was comparing number of bedrooms, number of bathrooms, and then the zip code, right? Would you want to average like zip codes together? Like it just doesn't make sense to do math with them, right? Because they're actually just representations that mean Ann Arbor, Michigan, or San Francisco, California, or whatever. So when you have data like that, you actually don't want to leave it as numeric, but you change that to categorical. So that way it just means this is a number that just represents this thing, this state. So I'm going to make survived from numeric into a categorical, from a numeric feature into a categorical label is basically the only thing. And I would want to keep this data. So that's what I think of with this class. The next thing is the passengers class. All right, so you can see that we have actually 3 unique values here from 1 and 3. Well, 1 is the max. Or sorry, 3 is the max, 1 is the min, so I'm guessing that the middle one is 2, but we can actually confirm that, yes, right here, by looking at this little layout right here, and you can see they are all 1, 2, or 3. And so you can actually see the kind of percentages here that 24% of this data is the first-class passengers, 21% is second-class passengers, and then 55% were the cool third-class passengers that were doing like the Irish dancing in the basement of the, or in the lower decks of the ship, since the movie Titanic was completely historically accurate. I'm sure of that. Okay, so this data, do you think that this is going to be relevant to whether or not they survived the class of the passenger? Yes, I think so too. And then what I would want to do, so yes, we're going to leave this in as a feature. Right now it is numeric. In this case, I would also make this one categorical, because really what you're talking about is like a first class, a second class, and a third class experience. So I would probably change this one to categorical as well. The next one is a name. So name is a string feature, and there are 891 unique values. When there are 891 unique values, and 891, when the number of rows matches the number of unique values in any column, that's probably not going to be a very useful column, just in general, words you could live by. So what this means is, so these are the individual names. And again, you wouldn't want a decision tree that said, if your name is, Leonardo DiCaprio, you're going to die. There's because somebody couldn't like scooch over a little bit on her little door or whatever it was that she was hanging on. But so these kind of things you don't want to do. Now, the machine learning purists know that there may actually be some signal in here, right? You could probably find like one of those things and do some kind of text analytics on the name. So if there was like a Vanderbilt or some of these other names that were historically known to be like well-to-do names, then perhaps those people would have a more likely chance of survival. So there may be some signal in there, but it's not worth our time. So I'm just going to throw that one out. So name, I think we're going to just pitch that. All right. The next one is gender. And for gender, we can actually look at the distribution because this is interesting as well. We have 65% male and 35% female in this data set. And so do you guys think that gender is going to be relevant to whether they survive? Yes, I agree. They did board the women and the children first, so being female may give you a higher survival likelihood. So we're going to leave this in as a feature. The one thing I would change here, though, it is a string. So I don't actually want to do text analytics on the word female and the word male, right? We don't actually care about that as a string. So that's another thing that I would change to categorical. So that's data that would make sense. We have male and female as two kind of discrete buckets. We don't need that as a string. So I'm going to make that categorical as well.
Could you plot two variables together, like if you want to plot this text with this survive?
Yes, great question. So being able to do visualizations in general, pause the recording. I use other tools than Azure Machine Learning to do my visualization. So to be fair, it's really good at what it does, but that's not one of the things that it's super good at, is doing a whole bunch of different visualizations like that. So I use other tools outside of this to do those comparisons and some of that data exploration stuff. And then when I import things in, I can just kind of deal with this part of it there. But it's a great question. That is something, but I usually do it outside of Azure ML, the visualization. Yeah. Any other questions? That's a good question. Yes, sir.
What do you use for your data visualization?
What do I use for my data visualization? That is a good question. So it varies. Sometimes I use tools like ggplot and stuff. It kind of depends on the format that I have it in. If it's in CSV, I'll use Excel. Like I'll just do it right in Excel and just because you can do some fancy pants charting right in Excel. Or I will use ggplot if I have the data in sometimes other formats. I use ggplot and we'll kind of draw things like that. So it really just varies. And then if you use R, there's different things you can do there too. So there's a lot of great things. But yeah, there's a lot of different visualization tools out there. Yeah. Any other questions? All right. So we'll jump back to the Titanic. So we're going to leave this as a feature, but we're going to change it to categorical. That's what we've decided on. Gender, fabulous. All right, the next thing is age. Oh, this one makes me so sad, you guys, because look, the minimum age was like less than 6 months old. Like, that's just heartbreaking. And then we had up to an 80-year-old on here. So age is kind of interesting. There's actually a lot of really neat things you can do here with age. So you can leave it as a number, and that's what I'm going to do just in terms of simplicity so that we're not here like all night doing kind of everything. But there's a lot of cool things that you can do with this data. So first, if you do exactly what he suggested, which is plot some of these things and how they correlate, you may find that, for example, there's like kind of the child experience, the adult experience, and the elderly experience, and those may correlate strongly to each other and to death. And that's actually really interesting because you see that a lot like in predicting disease. A lot of times there's and this is why we need algorithms that are nonlinear as well, is the disease things, because a lot of times the very, very young infants and the very, very old, the elderly, are way more susceptible to dying from these diseases. And so when you're trying to predict the likelihood, you're going to see something where like the probability is high or correlates strongly for very young and very old, and then the middle, it's maybe more likely to survive. But you're going to have a curve that looks like this, and no matter how hard you try, unless you get into higher dimensional polynomials, you're not going to be able to fit. You can't fit a line to this, right? You need a quadratic at that point. So really kind of interesting stuff. So you can do, so a couple different ways we could do this. We could make it categorical and say kind of 0, 1, 2 for I'm a child or an adult or elderly. Or you can do, just leave it as a age. You can also do, there's a lot of different things you could do. So data exploration and such is one way to do that a little better. All right, for this case, I'm just going to leave it as a number in there. But do you guys agree age would probably be relevant? Yes, because women and children were born at first, so that likely is. All right, the next two are interesting as well. So this is this SIB-SP stands for sibling or spouse, and this PARCH stands for parent or child. So these talk about the family units that are involved in the folks in the Titanic. So if I look at siblings and spouses and who they have, who has a sibling or spouse, you can see kind of some interesting data here. This 0, like there's up to, some people have 8 siblings or spouses on board. And then that goes, many people have none. So you could actually do a couple different things with this. So one thing that would be interesting is to combine them into like, am I part of a family unit or not? So you could turn this into a binary of part of a family unit or not part of a family unit. And that might be especially telling for the men, because I know if it was my family on board, I have 3 little kids, and my 3-year-old boy, he would be jumping off the lifeboat the first chance he got because he would think that was hilarious. And then, so maybe if you have a large family like these, 8 kids or whatever, and then you, maybe the man of that family is more likely to actually make it on board to help corral all of these children than a bachelor. So that there may be something to that as well. So you could use sibling, spouse, and parent-child to be able to do that. And there's just interesting data to play with here. So again, there's different ways that I probably process this with a little more time. So you could make these into a family unit binary or a couple different things. You could try to actually match up the families. Some people have done that as well. All right. So, but we're going to leave those in there as numeric features for now. All right. The next thing is ticket. So I would like to meet the person who designed the Titanic's ticketing system, because if you look at this first ticket, it is a letter, / a number, space, and a bunch of numbers. The second one is 2 letters, no /, a space, and a bunch of numbers. The next one is 4 letters, / letter, number, period, Ooh, we just threw that in there. And then a bunch of numbers. And then we have some that are just numbers with no letters. So I am actually going to throw out this data for two reasons. Number one, because I don't think the actual ticket number that's on the ticket is that relevant. And number two, because I don't want to parse that gobbledygook, because that's like, who designed that? So that's ticket. So it is a string. I think we're probably okay with not having that as a feature. Yes, Marcus.
When this is training, it's already been really just beating a dead horse.
Mm-hmm.
But couldn't you use the tickets as like a lookup to figure out where on the boat they were, if they're nearer to the lifeboat?
So we have cabin number as well. So I usually use cabin number to do that, but it's a great insight. So Marcus made the point that could we use the ticket number to look up where on the boat they were? And so that's a great insight. However, I'm going to use a different column. We actually have cabin number as one of the ones we haven't looked at yet. And so that's what I do. And if you guys, if you do, so we'll do that in just a second.
Are there fewer unique values for the ticket and the actual?
Why are there fewer? Good question. So I think my hypothesis on this, so the short answer is I don't know, but I have also noticed that, and my hypothesis is that a family maybe has one ticket for the whole family where it's like, here's the ticket, and then like there's 6 people on this ticket, is what I'm guessing, but I honestly do not know the answer to that. Does anyone know who's played with it yet?
Oh, sorry.
Yeah.
Cabin, you're missing data too.
Oh, yes. So missing values. So there's missing values show up in each one of these as well. So you can actually do some data cleaning on that for missing values. But that was my assumption. Since all of them have that just means that they've been reused a couple times. So since there's 0 missing values. Okay, so the next thing is fare. So how much did the ticket actually cost? So this one I think is a little more telling than the actual ticket because you can use this to kind of see, approximately how much they paid and get a sense for their maybe their clout on the boat. So there was a minimum value of 0, like some young ruffians that just gambled their way onto the ship 2 minutes before it departed from port. And then we have up to like $512, which was quite a lot in that time period. So you can see kind of the layout, and the majority of people paid. Is that many paid? Wow. So there's a lot of different values here, but you can kind of take that and look at the histogram to kind of get a sense for what that looks like. And then again, there's no missing values here, and then 248 unique values. Doesn't that drive you nuts? It's kind of like when you get asked to speak at a conference in Europe and you're like really excited. And so you check the ticket prices and it's like $1,000 and you're like, that's not that bad. So you go and you talk to your husband and you figure out daycare and you're like, I think we could maybe make this work. And you talk to your manager and he's okay with it. And you're like, oh, I think this might actually work. And then you go back and you check and you think you're okay. And then you go back and you look at the ticket price again and it's like $3,000. And you're like, laws of supply and demand and internet cookies. Why are you doing this to me? So it's nice to know that was still happening in the days of the Titanic, right? 248 unique values to different ticket prices for the same ride. Okay. Yes, sir.
If there were 8 tickets for the same family, would they all have the same price on the ticket value there?
That's a good question. We could probably figure it out from the data. I have not actually explored the data to that. That's a good. I haven't asked that question of the data yet, and that's a good question. We could do some code afterwards and figure it out. But yeah, I don't know. That's a good one. I have not looked at that. Any other questions I can't answer? Yes, sir.
Would you be able to cross-reference the family members and the cabin?
Yes. Yep. That's one way you could certainly do it. So the problem with cabin. Let's move on to cabin here. So first of all, you guys agree feature. Yes, for the fare, how much they paid is probably relevant. All right, and then numeric as well. Yes.
So we also have a column called passenger class.
Yes.
Yes. So
Yes.
The numbers may not agree with the passenger class. Like somebody may have bought the ticket earlier. And may have paid a lower price for the.
Yes.
For
yeah.
So.
Great.
The data is contradictory. Like, will it throw the model off?
Great question. So the question, if I can paraphrase for you, is sometimes there are two very similar data points that may be kind of correlated, and if you use them both as features, like how does that work, essentially? And the answer is it depends on the algorithm. It actually depends on the type of math you're doing. For some of the algorithms, that doesn't matter, and it will still
work around those, and for some of them it does matter, and having two strongly correlated things can be really bad. So unfortunately it's the architect's answer of it depends. It's dependent on the algorithm. But for this particular for the specific question that you asked, we could choose to throw that out and only focus on that, but that's one of the great things that you could do when you're iterating and when you explore the data is you can kind of look at the various things and see, okay, if I tried just this and exclude this, will I get a better, accuracy numbers and such than if I use both of them together? So that's definitely a question that we would ask when we're doing that. So you're definitely thinking the right way. I love it. Yes. Okay. So we're going to leave this one in as a numeric feature. Hopefully we're on board. So let's move on to cabin and the question that you were asking, sir. So yes, you can use the cabin numbers to find correlations between families and such. The only problem is for cabins specifically, there are 687 missing values. So there's a lot of families, there's a lot of people on board who don't actually have a cabin assigned. So all of the people that were doing the Irish dancing in the basement of the ship, again, on the Titanic, there's big kind of open areas in some of the holds and stuff. And then there were people who could afford the nicer cabins.
What I was thinking was that if you have like family members and have the same last name, then they'll probably be in the same cabin.
Yes. I would assume so too. It's another question we could ask the data to confirm that, but I think that sounds like a very sound hypothesis. Yeah, absolutely. And then the other thing is, then you would it's just that there's a lot of missing data. So, but when that's available, yes, that's a great thing that we can use to make correlations, and to find similar family members as well. So definitely. The only holdback is that there is a ton of missing data for this. So, there's a couple different ways we could process this. For this one, I'm actually just going to throw it out because I don't want to be here all night, but this is the only one that I really believe that this is totally relevant, and I am going to throw it out anyway just for time. But let me tell you what I would do with it when you go back and do this for realsies. So the cabin number, you can do a couple different things. So number one, you can just turn it into a binary of 0, they weren't in a cabin, make it a categorical variable where either 0, they don't have a cabin, or 1, they do. That's one. And then the other thing is, if you want to really have fun on a Friday night, there's actually maps out there of what the layout of the Titanic, and you can actually look up where all the different cabins are, and you can see like which ones were around the edge of the ship and closest to the lifeboats, and then which ones were more towards the center and like down certain levels, because it was like the ones that are up around the edge are closer versus when you go down and more towards the middle, it's harder to get to the lifeboats. So you can actually use all of that data to build like a little classifier for the ones that do have cabins. You can there's a technique called ensembling where you can actually use kind of multiple classifiers together to make an even better one. And so what you could do is just kind of grab the data that does have this and do some fun stuff with that as well. So that would be really, really fun. But unfortunately, we just in interest of time, I'm actually going to throw it out. But in real life, if you submit this to Kaggle, don't throw that out. There's actually some fun stuff in there. All right. Yes. Sorry. Your question. Come back to your question.
So I guess going back to like how fair is probably related to the P class.
Yes.
So a lot of the statistical algorithms assume that there's independence, but we know that there's probably some interaction between there. So is there a way to account for that in the Azure machine learning?
Yeah, great question. So there's a couple different ways you can do it. So number one, you can try dropping one and then the other and see which one is more relevant. The gentleman up front made a great point that is like the prices may go up or down based on how close you are to the Titanic, or maybe what the popular opinion was of the Titanic. If maybe the first wave of tickets went out and everybody was like super excited about it, maybe they were more expensive there, and then maybe something like early challenge, or something, something negative, and then maybe the ticket prices drop for a while. So there may be something where maybe the class is more telling than that. So again, you could try with one then the other and then see how well they work. The other thing is that there are some algorithms where that matters less. Like the way a decision tree works, decision trees are actually they're using information game theory to figure out what's the most relevant, and then so some of that will kind of be accounted for based on that. So you can if they're not independent, it's more okay. So there's some algorithms where it's more okay if they're not completely independent, like that. Great question. Any other questions? You guys are so much fun. All right, let's go back here. All right, so that's what we're going to do for Kevin. I'm going to throw it out for this thing, but it's really very useful. All right, and then finally, the embarkment point. So, fun fact, I did not know this, but there were actually 3 different embarkment points. The Titanic stopped at 3 different ports before it departed across the Atlantic. I did not know this prior to playing with this data set. But it actually stopped at 3 different things. The majority of people got on at Southampton, which is the S, but there were 2 other ports as well. So, I mean, what this tells us, since Southampton is like 72% of the data, that's one of those things where if you wanted to fill in a missing value or something, maybe it's safe in this case to throw in, Southampton for that one if you wanted to do that. And again, is this something that's going to be relevant or not to our algorithm? I don't know, but let's try it. Like, we can start and try it and see if there's anything in there and then throw it out if not. So we can try it as a feature. String, so I don't want to do text analytics on those 3 letters, so I would change this from a string to a categorical. Okay? All right, so that was my brain dump of how I would think about all this data, what I would process, why I would choose to make the decisions that I did. So now let's go and figure out how to implement all of that in Azure ML. So I'm going to turn this back to normal since I've been jumping in and out. Not that. Let's go to just a nice, oh no, I've already messed it up. Okay, so let's do, so the first thing I'm going to do is let's remove some data. So under data transformation manipulation, there is something called select columns in data set, and I should really do this properly. So once you kind of learn the names of them, the search is a lot faster to use, but in the interest of, since you guys don't know this as well, I should do this nice. So under data transformation, there's a whole bunch of different types of data cleaning modules and data transforming modules, filtering, manipulation, sampling, scaling, reducing, all these kind of things. So under manipulations, there's a whole bunch of stuff you can do. Oh, besides using Python and R modules in here, because you can drag and drop in a little Python script, you can drag and drop in a little R script. You can also do SQL transformations. If any of you guys are SQL people, I love that just for group by. Like, group by is awesome. Like, if you want to aggregate some data, I can just do a select group by, and then I'm just like, yes, and then it does really nice aggregations for you, and it's actually really fast, too. So that's a really nice thing. So you can kind of use some of those 3 languages in there. So SQL and R and Python, whatever you're comfortable if you want to write custom code. All right, so I'm going to take this data, and you can see this turns green to tell me, yes, this is an acceptable data type to pass in here. And then it tells me that there's a little bang here because I need to actually fill in some information. And so when I have this selected, this will contextually pop up whatever's selected here. So in this case, select columns in data set. It's going to say, what columns do you want to select? And so I'm only going to carry forward certain things. So now we have to remember everything that I just said and do that over again. So passenger ID, we wanted to pass. This was something we were going to keep with the data, but we have to set it to be not a feature. So we're going to keep that. Survived, we're going to keep. Passenger class, we're going to keep. Name, we're going to throw out. So let me just push those over. The gender, we're going to keep. Age, we're going to keep. These 2 we can keep for now. Ticket, we're going to throw out. Fare, we're going to keep. And embarkment point, we're going to keep. And then cabin is actually really relevant, but we're going to throw it out just for time. Okay. So there we go. So now, if I actually run this, you'll see that there would only be 9 columns coming out instead of 12, but I'm going to wait just a second to run it after I do a little more stuff. Okay, so the next thing I want to do is this edit metadata. So I can change various things about my data. So let's make a couple of changes here. So the first thing I want to do, and for each one of these, when you edit the metadata, you just tell it what, you can make a bunch of changes right here, like changing the data type. So for example, if you have a date times are hard to deal with. So if you change it to an integer, then that's nice because it's easier to do math with and stuff like that. So you can switch between date times. You can make things categorical. You can change the fields like so, and then you can actually rename columns as well right here. So what I'm going to do first is let's deal with the passenger ID. So you can start with everything and then just exclude the things you don't want, or you can start with nothing and just include the things you do want. So I'm going to do passenger ID first and say the passenger ID for this one, I want to, in this, everything by default is treated as a feature. As you probably saw when I was looking at all those data, everything was created as a feature. So what I'm going to do is select clear feature. So that will keep the passenger ID associated with each row, but it won't be treated as a feature anymore. Okay, so it won't be used as a kind of an input to my algorithm. All right, it'll just be passed along. So I'm going to do clear feature on that, so it won't be a feature anymore on just passenger ID. Then, since I want to deal with some different columns, I have to drag another one. And let's pass that in as well. And then what I want to do here is let's do the survived column, the next one. And this one, survived, we wanted to make, that one was originally a feature, and we want to make it a label. So I'm going to change that one to be a label, like so. So survived will become a label. Then the other thing I wanted to do was make a bunch of stuff categorical. We threw out some stuff. We can make some stuff categorical. So let's launch this again. And once I run it, it'll actually parse it down. Right now I haven't run it yet, so it doesn't, it's still showing me everything. But once I run it, it would see that there's only 9 columns there now. Okay, so categorical, we want to make survived categorical. We want to make the passenger class categorical. We've thrown this out. Gender should be categorical. That's a number, 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 that's thrown out. And then embarkment. I think embarkment we want to make categorical as well. Okay? You guys remembering all this from 10 minutes ago? Okay. So then what we're going to do is take all of these under categorical and say make categorical, and then it will do all of those columns all at once. Okay. And then I think that's all I need to do, right? Do we have pretty much everything? Let's change this name to, where am I? PyData AA. And then Titanic. And then we'll save this. And then we will actually run it. And this is, so now it is running. It will take just a second to do that. And while it does it, just to get us in the mood. Oh my goodness. Oh, her story. It's really a very big ship. Oh, it's done already. Oh, Azure Machine Learning, why are you so efficient? Okay, so we're going to start with the experiment. So let's take a look. I'm going to just test right here and right click and hit visualize just to see where I'm at. And so just take a quick look. So we can see we're down from 12 to 9 columns. So passenger ID is just a numeric and it is not a feature. Good. This should be a categorical label. Good. This should be categorical feature. Good. Good. Numeric feature. Good. That's what I want. Sibling spouse. Good. Yes. Numeric feature. That's fine. That's fine. That's fine. And categorical. Perfect. All right. So I think that's what I want. So I think we're ready to split our data now. So now I'm going to go here in data transformation, and there is a sample and split here. And I'm just going to do a split now. And when you do rerun stuff, since I haven't changed any of this, it will just do these all super fast. It caches all of this stuff for you. So that should be pretty easy. You can actually split by regular expressions and do all kinds of fun splits here. I'm going to just pretend like my data set is large enough that it doesn't matter and use law of large numbers to take care of randomization for me. But I'm going to say 70. So this is actually the fraction of rows in the first output node. So if I say 0.7 here, that means that 70% of the data will come out of here and 30% will come out of here. And then you can do things like stratified split. If I wanted to make sure that the same number of like survived and died went on like this side and this side of the data, you can actually do that as well. Yes, sir.
How are we going to deal with the missing value?
Oh, yes, you're right. I think I did have some missing values and I skipped over that. So there's a couple different ways you can deal with missing values in general, and it all depends on the number, like what your data looks like, right? So if you have some things, like for example, the port one, where there were a couple missing values for that one. In that case, like the majority of the data came from Southampton, so in that case, it may be okay to fill in a default value of Southampton. In other cases, when you have missing values, sometimes you can actually do another machine learning thing to actually predict based on these other features, what do I think the value here is, and do it that way. Sometimes you can throw the data out. So it really depends on the data, how you want to handle that and kind of your confidence levels and what you're trying to predict. So another kind of it depends question. I'm actually going to keep going for now, but I can show you afterwards. There's different ways to deal with missing data in here as well, just because, we're running out of time. So I'm just going to keep going on that, but that's a fabulous question. Okay, so splitting the data. So we're going to split the data. Then I'm going to build 2 of these in parallel just to kind of show how it works. We're on to the machine learning fun stuff. So I'm going to choose 2 models, and you guys already correctly said that classification was what we wanted to do this. And so typically, if you don't know much about the data set, you might want to start with maybe 1 linear and like 1 nonlinear algorithm. If you haven't done any exploration, if you're just playing, otherwise you'd look and kind of see correlations. So I'm going to grab a 2-class logistic regression and a decision jungle. A decision jungle is a ensemble of decision trees, kind of like a decision forest, only it doesn't grow, and they actually fork them back together at the end in decision jungle. There's a paper Microsoft Research did on it. And then we want to score our models. We want to train our models first. Let's train our models first, and then we'll score them. So train models. So for my train model, I'm going to pass in an untrained model. And so note how one of them turns green and one of them turns red on me. So it's telling me basically here's the data type that's okay to pass in. So I'm going to pass in that to one trained model, and I'm going to do a second one in parallel to try both of them. Pass that in, and then I want to train with my 70% of the data here and 70% here. And then I'm going to see the one thing it's saying is it's asking for my label column here. So I'm just going to say survived is my label, and survived is my label here as well.
Is it doing hyperparameter optimization?
Great question. So there's actually a way to do that. There's another module that you can do to do that. So if you want to do hyperparameter tuning, there is a tune model hyperparameters, and you can stick that in there, and then that will actually try a variety. You can pass in a range, and it will try everything within the range and then output the best one for you. So yes, we do have that capability. Yes, sir.
What's hyperparameter optimization?
Okay, so great question. So let's say that I have a whole bunch of data. I'm going to try to talk and do this at the same time, which may or may not work. Let's say you have a whole bunch of data, and for each of these models, click on one of these. So for each one of these models, there are a whole bunch of different things. There's these regularization weights, there's memory size, there's what do you want your optimization tolerance to be. So every single machine learning algorithm has its own little parameters and stuff that you tweak, all right? And so a lot of times when we're doing it in the real world, we just try a lot of different things, and then we iterate until it works, right? So what this does is if you use the tune model hyperparameters, instead of saying single parameter here, you would say, give me a parameter range, please, and then you stick a hyperparameter in there, and what it does is you can say, all right, try values from here to here, and then it will try a whole bunch of them, so a whole range for each one of these values, and then you can actually, it'll pick the best one that gives you, you can say, here's the thing I want you to optimize for, like accuracy, precision, recall, whatever, and then it will give you the best model from that. So it'll kind of automate some of that work for you. Yes, sir? We do. I mean, there's various things that you can use in libraries and stuff that help do that for you. So yeah, no, there are ways to do that. Yep. Yeah, no problem. Great question. Okay, and thank you for keeping me honest. Forgive me that I forget sometimes. Okay, so now I'm going to do 2 score models. And so what the trained model, that outputs a trained model. So I'm going to stick this into score, and then we're going to take that 30% of the data that we held back and see how well it does. So I'm passing my trained model here. And again, I'm going to take 30% of the data that it hasn't seen before and see how well it does with that. And then finally, I want to evaluate those 2 guys side by side to see how well they do with each other. So I'm going to say stick an evaluate model here and then pass in the logistic regression and the decision jungle one by one. And then we are going to save that bad boy and we are going to rerun it. Okay.
More than 2 models, can you evaluate more than?
Say that one more time, please.
If you're using more than 2, you're training more than 2 models.
Great question. So the question is, if you're training more than 2 models, can you do that well? The answer is actually no, like the way machine. So you can, but what you evaluate model only takes 2 inputs. So what you can do is, so there's also a convert to CSV. So you can run another one right here and another one right here, have a bunch of evaluate models, and then join them all together. There's a join module, and then like dump them to CSV and then just take the CSV or something, or you can just right click on each of them and evaluate them all separately. But yeah, but right now for the way the evaluate works, it only takes 2 inputs. Yeah, but great question. Yep. All right, so I'm going to right click on the output of this visualize module. And then what it does is it draws a curve for me. So let me tell everyone what this means for those that aren't familiar. So what this is actually plotting is the true positive rate against the false positive rate, okay? And so when you think about it, false positives are bad. That's when you say something is true and it is not true. And then true positives are good. We want that to happen. And so perfection would be 0 false positives, right? So you're going up this side. And then the true positives would be 100%. So 1, and then across here. So this boop is perfection. So the tighter you hug that curve, the better your machine learning algorithm is doing. So it's hard to see on a projector, but this diagonal line right here, sorry, I should be doing it on this for the recording. This diagonal line right here, so this is perfection, across like that. The tighter you hug this curve, the better your algorithm is. And then this diagonal line is essentially 50-50 random chance, a monkey flipping a coin, right? So if your algorithm is not doing better than that, maybe start over, look at some different features or something like that. Okay, and then what I can do is I can actually compare the two of them. It actually looks like the red did a little better. It tells you that the first one is going to be the first one that came in from the left-hand side is going to be the blue, and then the second one is going to be the red. So it looks like this. So if we look at our first one that didn't do quite as well, you can see for each of these, it gives you the numbers. True positives and true negatives are good. False negatives and false positives are bad. And then it gave us an accuracy number, precision recall, F1, which is a combination of precision and recall, and then the overall area under the curve, which is all of them. So what we can see is that here, this one actually did better, and it had an accuracy of about 81%. So I'm going to choose that. So just thinking about that, let me train this in. So this one was doing a little better, so I'm actually going to set this up real fast. Basically, I could have done that in like 10 minutes if I wasn't talking through everything. But in like 10 minutes, I was able to build something that was able to predict this survival rate with 80% accuracy, which is kind of cool, right? So when you think about the business problems that you're dealing with, for those of you in industry, or some of the cool problems we're trying to solve in academia, like it's really neat to be able to have a tool like this that can let you kind of try different things and such. Okay, so what I did was I just hit, I chose the one that had the higher accuracy. One of them was like high 70s. The other one was 81. So I chose the one that was 81, which was the decision jungle. And then there was a really cool animation that I'm sorry that you missed, but basically it took the score model, train model, that kind of garbage stuff we were training the stuff, and then it kept in my data cleaning, and then just passed that to that trained model that I built. And then if I deploy it, like so, it actually deploys out, stands up a REST endpoint, and then generates sample code for me in a bunch of different languages, which is awesome. So let me just show you this really quick. If we want to, it's creating this experiment, and it's done. So if we want to just see, one other thing, the documentation for this is fabulous. Let me just say right here, so it generates a help page for you. So if you are a developer and you just want to pass this to someone, it tells you, okay, here's all the request headers you need to send. So first of all, it gives you sample code in a bunch of different languages. If you don't want to use one of those 3 languages, then here's the request headers that you send. Here's what the request body should look like. Here's what a sample request should look like with all these values passed in. Here's the response codes that it will return. Here's a sample response, and it kind of gives you what all of that look like and the data types. And then here's the input parameters and what they look like. And then it even extrapolated from my data. Here's the allowed value. So in case I forget, is it, female or male or F and M? I can just point someone to this. So I created this thing. So maybe I'm the machine learning person on my team. I create this, then I take this web page, I point my developers to it, and I'm like, code to that. And then they're like, got it. And it's really awesome. So that's cool. And then here's the sample code. So there's sample code in C#, Python, and R. So it auto-generates those for you. If you're a C# person, you can just copy and paste that into Visual Studio, and you just hit run and it works. Same thing with the Python and the R. So it's just like, here's how it works. And then one final thing I want to show you really fast. Actually, let's do one quick test too. Let's test to see if it works. Okay, passenger ID. The maximum number was 891, so we're going to do 1,000. Survived, we don't know yet, so I'm going to blank that out. Let's say a first-class passenger whose name was Rose, and she was female, and her age was, how old do you think she was? Like 21-ish, maybe? She's 19. Oh, okay. Sorry, 19. And she had 0 siblings and spouses. She was engaged, but she didn't technically have a spouse yet. And then parents, children, she had one. She had the mean mom, right? So the mean mom that wanted her to marry the rich guy. So one parent, and then the ticket I can basically just bang on the keyboard because that's what their ticket format looked like. The maximum fare was $512. So I'd be willing to, she paid at least $400, right? You think? 400? All right, so probably more than that. Yeah, probably $450 maybe. So we'll do that. And then cabin, we do know she had a cabin because she was modeling necklaces in her cabin. So let's just choose I'm just going to choose a random one. And then embarkment point, I don't know, but I'm going to pick Southampton because it was the most common one. So it sends this up, and then what it does by default is it's returning all that data. So here's all the data we sent up, and then it is the last 2 parameters are what actually give us the thing. So we can see that she did survive, and we have a 98% confidence that she would survive. So that's very cool. And then the one other thing I want to tell you about, I'm sorry, Sean, one last thing is just that there's also all of this wired up as an Excel workbook. So this is awesome if you guys are working with business analysts or non-coders. So what they give you is, let me just open this just to show you. I won't run it, but just to show you. What it basically does is it wires up everything using Excel macros to call your service. So I need to enable it once because I downloaded it from the internet, and that's bad. And then I have to enable it again because it's running macros, so I have to say, okay, again. And then what it does is it gives you all of those various, your inputs, and then you just basically type in the columns, okay, for this passenger ID, and then you just fill in values here, and then it calls, and in the real life, I would actually do another select thing and remove, so I'm not passing everything back, but then you could actually get these predictions back, okay? So kind of a cool thing to have that automatically done in Excel too. So then if you have a business analyst, you just hand them that, and then they can use your model without even needing code. They can just do it all through Excel. Okay, so that's the deployment thing. So that's why there are people that are taking just like a single execute Python, sticking it in Azure Machine Learning and hitting deploy and using this just for their deployment story because it's fabulous like that. Okay, I think that is everything. I apologize for running over, Sean. But that was everything. If you guys have any other questions, I'm happy to stay a little bit. Thank you so much.
We are running a little bit late, but I also want people to be able to grab pizza. So maybe instead of doing questions up here, let's move over there and get some food. And hope everybody enjoyed this. Thank you.
Yes, thank you, Marcus.
And grab a